So let me conclude in five minutes. Let me conclude the abstraction, and then I will come to a concrete example in which I will explain all the abstractions that we have done so far. So pricing and hedging, these are the two central issues, right? Pricing is important because the buyer wouldn't like to give 1 paisa more than the necessary, and hedging is of utmost importance. So how do you do pricing and hedging if the market happens to be complete, right? So we have a market that is known to be complete. We have tested that. That means we have tested that there exists a unique equivalent martingale measure, and therefore it is arbitrage free and every contingent claim is attainable. So let H be a contingent claim. H be a contingent claim. This is vis-a-vis the abstract market that I have defined before. So the end of the day is capital N. Now H is a contingent claim. Now since the market is complete, it's both arbitrage free and every contingent claim is attainable, right? And by the second fundamental theorem of finance, let P star be the unique EMM. It exists and is unique. Since it's complete, there exists only one risk neutral measure, one equivalent martingale measure, right? And H, by the completeness, H is attainable, right? So let phi equal to phi n, the sequence, be a replicating strategy. Let phi n be a replicating strategy, i.e. H is equal to Vn of phi, right? That is the definition of a replicating strategy. Therefore, this implies 1 plus r to the power minus n h is equal to Vn tilde phi, right? Therefore, expectation with respect to this 1 plus r to the power minus n h, given information at an earlier time, little n is an earlier time, this will be conditional expectation of Vn tilde phi given Fn. But I know from the theory that Vn tilde n is a martingale, right? So this is going to be equal to of phi, right? So writing it the other way, Vn of phi, this is a constant, right? It can come out of the expectation. This is 1 plus r to the power that's right. Now let's interpret this result. This is just a simple consequence of the fact that the market is complete and therefore the claim is replicable, attainable. So we have replicated it using a self-financing strategy, and then we have used the martingale property. Now look at this. This is the value of the portfolio at time n, and this is equal to the conditional expectation of h given n multiplied by the appropriate discount factor. So this much wealth is needed to generate h, right? So this is the option price. Remember, if I write it like this, I can take this inside, right? This is 1 plus r minus n h given fn, right? So this is the present value of h, right? The value of h at an earlier time is the present value of h vis-a-vis the numerator, right? And I am taking the conditional expectation with respect to not the original measure, not the market measure, but the unique equivalent martingale measure. So that is the wealth. So it's the expectation of the, it is the conditional expectation of the present value, but conditional expectation has to be taken not with respect to the subjective measure, but with respect to the objective one, because it's a complete market. No matter who decides what, everybody will come to only one equivalent martingale measure. Therefore, this is unique option price. And what is the hedging strategy? Fine. Hedging strategy need not be unique, right? Any strategy that gives you hedging is fine. And therefore, the writer is perfectly hedged. He has no risk whatsoever, because he will take this much amount of, if suppose I am the seller and you are the buyer, so you will give me this amount of money, right? And I will use this amount of money to make a portfolio, right? Invest in various stocks. At the end of the day, I will replicate H, right? So I have no loss at all. So the writer is perfectly hedged. So he has absolutely no risk. An option writer or option seller has no risk whatsoever in a complete market. On the other hand, you cannot get cheated, because you can calculate this. If you know the market model, which I am coming in 2 minutes, then you can calculate V and phi. If you know the distributions of all the market instruments, then you can calculate this conditional expectation. Once you know the conditional expectation, you will not give a paisa more than that. So from the buyer's perspective, it's unique, so you will never get cheated. The writer is completely hedged, right? And now what you can do is, suppose you are buying an option and keeping it quiet, then your loss is maximum this, right? This is your option price. Cn is going to be equal to, option price is going to be equal to Vn of phi. This is the unique option price. But if you keep quiet, you may lose Cn. But you can also, because buyers and sellers roles are dual to each other, right? You can also hedge yourself. Do whatever the buyer does, do exactly the opposite. So you have bought, that means you can also invest in the market, and you can also, in a complete market, if you do the opposite hedging, right, then you will never lose anything. So typically, if you buy a call option in a complete market and do appropriate hedging, that means invest in the same market, then you will also lose, you won't lose any money. So you can also do the hedging. So in a portfolio, everybody adds, other than the stocks, options also, because that gives a diversification. Now the question is, these are all abstract. Let's do a concrete case, apply this theory. So this is the called Cox-Ross-Rubinstein model, or this is called CRR model. Another name is binomial model. If you read a book by Stephen Shreve, then he has done it using a tree. Okay, so what's a binomial model? Let me explain. And then So there are two bond, I will denote it by Sn0. This is 1 plus r to the power n, and a stock. There are only two instruments, a bond and a stock. That's the market, right? Now, as I said, since this is going to be a concrete model, so I have to tell how the stock prices move, how the stock prices change. Okay, the stock prices changes as follows. So let A be two numbers, -1. These are the two numbers satisfying this, such that Sn plus 1 is equal to Sn times 1 plus A with probability P0 and Sn times 1 plus B with probability 1 minus. So there are only two possibilities. There are two numbers, A and B, satisfying. Why this restriction? Because I want the stock prices to be always non-negative. It should, stock prices can never be negative, right? It can be 0, which is called a junk stock, right? But it can't be negative. So A must be greater than, strictly greater than -1 and less than B, right? So why it is called binomial? Because at every step, the next has two choices only, right? Sn, from Sn, there is Sn plus A1 plus probability P0, and then 1 plus B with a complementary probability. There are two choices. And in these two choices, we will prove the following, that the market is complete. That means it is arbitrage free and every contingent claim is replicable. That means we will show that there exists a unique equivalent martingale measure. Right? The moment you add three possibilities, the market is arbitrage free but not complete. If it is not complete, then you will have several definitions of option price and there will be contingent claims which cannot be replicated. Right? So this is the only market that is complete, binomial model. In discrete time, this is the only market that is complete. And in continuous time, I will show you that there is only one market that is complete, namely Black-Scholes market. Now here, it doesn't mean, look at, -1 is less than A, less than B. It doesn't mean that this is down or this is up. Both can be up, up. Both can be down, down, up, down. All possibilities exist. Because I have not restricted, only I have said this guy is bigger than this guy. But both those guys, Sn plus 1 may be less than Sn in both possibilities, more than Sn in both possibilities. But this is higher than this. So you can call it up with this probability, but down is not the correct term. Now, since this is a binomial, you can draw the tree and you know the price, the option price is Sn minus k plus, right? So you can come back at any and decide what the price is. No sophisticated mathematics is needed, and if you want to see that, you can see Stephen Strebe's first volume, Stochastic Calculus or something. The first, he has not used any martingale theory. The question that arises that why am I doing martingale theory? Now the moment from the market moves in continuous time, not in discrete time, right? Discrete time is more complicated because if you have lot of data then discrete time becomes almost unmanageable mathematically. So why am I doing this? The reason I am doing this is the continuous time, mathematical theory of continuous time option pricing is a minefield. You need at least 5 to 6 courses in probability and stochastic process to have any understanding of continuous time mathematical finance, and I just have 1.5 hours, so I can't do that. So I will not be able to explain all the concepts and the technical details in continuous time, which is the real one. Here it is relatively much simple, which I have finished in 3 hours. Right? Now let's do this and get a feel for how the martingale theory works. Martingale theory is a very powerful tool because after all, what is the option price? Option price is a conditional expectation, right? Right? So conditional expectation can always be computed, whatever be the model. Conditional expectation can always be computed by Monte Carlo. So you have a very powerful tool to compute the option price, and that is why the martingale. So if the distributions is more complicated than the binomial, still you have this abstract mathematical formula gives you a tool to find out the option price. In reality, nobody hedges, so nobody worries too much about hedging, because hedging is very difficult. So this is the model. So I want to show the power of mathematical theory through this simple model. Now here is, when I'm talking about, there is a market probability, right? There is a market probability, right? And then I have to introduce a probability with respect to which all the discounted stock prices are martingales, and then I will use this abstract formula to compute what can be done by binomial tree as well. So let's do that. So I have to have omega, and I have to have f, I have to have p star. To begin with a p is already given. I have to have p star, right? Now what's more important is not the stock price, but their relative change, right? So I will introduce a random variable Tn equal to Sn plus 1 over Sn. Let me be consistent with my notation. No. This is my Tn. Same thing, but only the n equal to. So this is the relative price change. So what are the possible values of Tn? What are the possible values of Tn? Either 1 plus A or 1 plus B, right? So that makes it easier, okay? And I will always assume that S0 is given. S0 is given. That will make the initial sigma field trivial. Now I will, so what is omega? Omega is basically 1 plus A, 1 plus B. This is a set, and take the n product. Right? This is the Cartesian product of 1 plus A, 1 plus B, two values, 1 plus A, 1 plus B. How many times you have multiplied? N times. Right? So what is each omega? Each omega gives you the successive values of relative changes in this sense, right? Successive values of Tn, right? So there is a market probability, right? So omega, what is omega? Omega is x1, x capital, this, right? x1, x2 up to xn. So what is xi? What are these values? An n tuple, right? An n tuple in which each one is either 1 plus A or 1 plus B, right? So, so this is a typical omega. So how do I define the market probability? The market probability, if I have such omega, that is x1, xn, right? This is omega, right? This is the original probability that I have been given. So I will write probability T1 equal to x1, T2 equal to x2, right? So now I have omega fp. What is f? This is a finite set, right? Whenever I have a finite set, what is f? F is the power set, right? And this is the probability. This probability is uniquely defined in terms of the given probability, right? Now what is my Fn? Fn is the sigma, the information by observing this, right? Which is the same thing as observing essence, right? If you know essence, you know TNs. If you know TNs, you know essence. They are equivalent, right? So this is my Fn. You can clearly see that f of 0 is the trivial sigma field, because I assume that S0 is given, and f of n all possibilities. Now what is the task now? If I have to give an example of the abstract theory, I have to construct a P star, right, such that the Sn tilde are martingales. Then I can use the abstract formula, right? An abstract formula will give me everything concrete. Not an abstract, but the hedging will be explicit, the pricing will be explicit, everything in terms of the given quantity. What are the given quantities? Given quantities are 1 plus A and 1 plus B and P0. There will be a surprise, P0 will be missing from the scene. Okay, fine. Now I claim the following. This sequence, now I will concentrate not on the Sn sequence, but I will concentrate on the Tn sequence, right? Because Tn sequence completely generates the Sn ones and vice versa. Okay, so I claim the following. Sn tilde is a P star martingale if and only if E star Tn plus 1 given Fn is equal to 1 plus R. Now why should I think that this claim or lemma should be true? What is Tn plus 1? The relative change, right? The relative change of the bond is 1 plus R, right? Bn plus 1 divided by Bn is 1 plus R, right? So if Pn star has to be a martingale measure, the game has to be a fair one, and this should be true, right? Now I need to prove this, right? So so now the proof of the claim. I need to prove these claims, right? So proof of the claim, right? Sn tilde is a P star martingale if and only if, this is the definition, right? This is the definition of martingale, right? So this is, I can take 1 plus R to the power minus n plus 1 E star Sn plus 1 given Fn equal to 1 plus R to the power minus n Sn, right? Right? This means expected value of Sn plus 1 over Sn given Fn equal to 1 plus R. So I have proved the claim, and I have indicated right in the beginning, right, that Sn tilde is a P star martingale. I have to find such a P star. So I am just seeing if Sn tilde are P star martingale, what are the consequences? The conditional expectation of Tn plus 1 must be equal to 1 plus R, right? Now my second claim, these are very, very simple, that's why I am explaining it. Tomorrow I won't be able to prove much. This is claim number 1. Second claim, the market is viable if and only if R lies between A and B. You can't choose arbitrary R. Given A and B, R has a restriction. That means if you are given an R, okay, you have restrictions on A and B. A and B must satisfy this restriction because the stock has to be non-negative, but R must be this. Now what is arbitrage free? That means Tn plus 1 must be equal to that. Now you look at this. This is true, right? So this implies you can take one more expectation, and conditional expectation of conditional expectation is expectation, right? That's called the law of iterated expectation. E star of Tn plus 1 is equal to 1 plus R, right? Now what is Tn plus 1? It's basically a Bernoulli random variable, right? It is 1 plus A with probability P0 and 1 plus B with probability 1 minus P0, and both are positive, right? Right? And therefore their mean must lie between the two. That immediately tells me that 1 plus A must be less than 1 plus R must be less than 1 plus B, right? Finished, right? So this claim is also simple. So now I know that R strictly lies between A and B, right? Now I want to start cooking up a probability measure. Remember, those are the the claim is a characterization. Second claim is also characterization of the viability. This is incorrect. This is an incorrect. What I proved is one-way inequality, right? One-way inequality. So what I have proved is for the market to be arbitrage free, for the market to be viable, this is a necessary condition. We have only proved a necessary condition, right? Not if and only. Sorry. For the market to be viable, R must lie between A and B. Okay. Now my next claim is I am now going to cook up a probability measure. So let P be equal to B minus A over B minus R over B minus A. This is a positive quantity. Right? And this quantity has nothing to do with P0. Right? Now, now the next claim. Sn tilde is a P star martingale if and only if TNs are IID with what is IID? Independent and identically distributed random variable. So my aim is the following. If you are, it's not a mystery story that we are going to reveal at the end. What am I trying to do? That under the probability measure, the distributions of T1s are known, but they are all dependent random variables. I would like to make them independent random variables, and I would like to make them identically distributed. Why I am doing so? I have to do what is my Cn? Cn equal to 1 plus r to the power minus n expected value of Sn minus k plus over Fn, right? Now this Sn can be expressed in terms of Tn's, right, easily, some product, right? And if they are independent, then Sn will be product of Tn's, okay? And if they are independent, it's very easy to calculate the expectation, right? So therefore I want to make them independent. If I additionally make them identically distributed, then all of them have the same, so it will make life easier. So I claim that if P star is an equivalent martingale measure, if and only if Tn's are not only independent but identically distribution with their, all of them have the same distribution, namely T1 is equal to 1 plus A with respect to P star is this P and the complementary, because there are only two possibilities. Let's prove this. So proof of the third claim. So if you want to call it claim 1, claim 2, claim 3, I am now proving claim 3. Now so I have to use the subsequent previous claims. So Sn is P star martingale, right? If it is a P star martingale, if and only if the first claim is true, right? First claim tells me that E star of Tn plus 1 given Fn is equal to 1 plus r, right? This tells me that E star of Tn plus 1 equal to 1 plus r, but Tn plus 1 is a Bernoulli random variable. Bernoulli in a generalized sense, it occupies only 2, right? So this is 1 plus A times P star Tn plus 1 equal to 1 plus A plus 1 plus B P star Tn plus 1 equal to 1 plus B is equal to 1 plus R, but A and B has a relationship. A and B we can, okay. So this, if we simplify, no, let me do the other way. So this will be if and only if. Suppose Tn's are IID with the above distribution, then this is if and only if right. This will be equal to, suppose Tn's are independent, then what will be the expected value of Tn plus 1 given Fn? It will be expected value of Tn because it is independent, right? And this is equal to P times 1 plus A plus 1 minus P times 1 plus B, right? And you can calculate and check that this is 1 plus R, right? So this means I have used the identical, I have no, I have proved only one way, right? I have proved only one way, right? I have to prove the converse, okay? So to prove the converse, one way, right? Suppose Tn's are IID with this distribution, then I have proved only one way. Then this is true, right? Then this is true, therefore these are martingale. Now I have to prove the other way, right? Conversely, converse is a little more complicated. Conversely, suppose Sn tilde R P star martingale. This implies expected value of Tn plus 1 given Fn, this is equal to 1 plus R, that we have seen, right? This implies expected value of Tn plus 1 equal to 1 plus R, one more expectation, right? This will imply 1 plus A Tn plus 1 equal to 1 plus A plus 1 plus B one minus P star Tn plus 1 equal to 1 plus A is equal to 1 plus R, right? Because there are only two choices. There are only two choices, right? So this will give me, that P star of Tn plus 1 equal to 1 plus A is equal to, you have to just simplify it, B minus R over B minus A. You can simplify and check that, right? And this is equal to P. So what have I proved? I have proved that the Tn's are identically distributed, right? The distribution here, that Tn plus 1 equal to P does not depend on n, right? For any n this is true. That means they are, this implies Tn's are identically distributed. right? I have not proved them to be independent. Independent will take a little more time. So just identically distributed we have proved. Okay, now I will prove that they are independent with an exercise. Okay, now again we'll keep repeating the first claim. Again, E star of Tn plus 1 given Fn is equal to 1 plus R. I am continuing with this, right? So this means but Tn plus 1 is a Bernoulli random variable. It has only two values. So even with respect to conditioning, I can use that conditioning. So therefore, this will imply 1 plus A expected value of indicator Tn plus 1 equal to 1 plus A given Fn plus 1 plus B, conditional expectation of indicator Tn plus 1 equal to 1 plus B given Fn is equal to 1 plus R, right? But these two are complementary events even conditionally, right? And therefore the conditional probability of one must be 1 minus the other, right? So if you do that and simplify, you will get that P star of, this is P star, right? This is the conditional probability of, this is conditional probability of right? Similarly, this is conditional probability of, this is conditional probability, and these conditional probabilities are complementary, right? So this quantity is 1 minus this quantity, right? And therefore if you do that, then you will find Tn, the calculations you do it yourself and it's given in my note, 1 plus A given Fn is equal to P is equal to 1 minus P star you can check this. Therefore the conditional probability of Tn plus 1 given Fn, it doesn't matter what n is the same, right? Using this, again exercise, this is an exercise which takes 2 minutes to solve, and I suggest you solve it. This is an exercise. Okay, this up to this is clear, right? You have any question? So this is an exercise now. If you solve the exercise, see, remember mathematics, the only way to learn mathematics is to do it. If you carry out the exercise and you have any difficulty, which means you had some difficulty in understanding the concept. So this is a test whether you are following it or not. So solve this exercise. Using this you can prove the following. P star of T1 equal to x1, T2 equal to x2, Tn equal to xn is going to be equal to P1, P2, Pn, where Pi equal to P if xi is equal to 1 plus A, Pi equal to 1 minus P if xi equal to 1 plus B. Is that okay? I will explain. Yeah. Some typo? Where? 1 plus B. No, This is fine, right? Here, no? So up to this I have proved, right? It's a matter of just simplifying. Up to this I have proved, right? Now you look at this. I have proved this for n equal to just 1n. How would you prove this? This is an exercise. Okay? For 1 I have proved. For n equal to, if here there is only 1, I have proved. Right? Now go inductively. For 2, how would you prove for 2? Probability is very simple, right? If you want to T1 and T2, then T1 you already know, right? You want to find you know the individual distributions of T1 and T2. You want to find the joint distribution of T1 and T2. How do you do? By conditioning. Use the conditioning and prove this, right? So I am just telling you how to go solve this exercise. Once you solve this exercise, probability P star of T1 equal to x1, T2 equal to x2, Tn equal to xn is P1, P2, Pn, where Pi is equal to P if xi is 1 plus a, and Pi equal to 1 minus P if xi is 1 plus b. Assume you have solved the exercise, right? So what is the consequence? We have already proved that they are identically distributed. Now what is the proof? They are independent, right? So if you have solved this exercise, then it immediately shows, this implies that Tn's are IID. So where is my claim? This claim has been done. Now let's take a hard look at what we have proved. Sn tilde are P star martingale if and only if Ti's are IID. Not only IID, their distribution is given by this. Given by what? That the joint distribution of T1 through Tn is equal to P1, P2 times Pn. And it follows only from this, right? This gives both the existence and uniqueness of a martingale measure, because such a thing I can always define a P star through this, okay, and I can reverse the arrows. This will give me an existence, right? And how would you prove the uniqueness? Because the arrows are reversible, anything that satisfies this will satisfy this. So this is the defining property of the joint distributions of T1 through Tn. The joint distributions of T1 through Tn is defined by the product of P1 through Pn, right? And what is Pi? Pi's are either P or 1 minus P, based on whether xi's are 1 plus A or 1 minus B, right? And therefore what? The binomial market is viable and complete. Therefore, CRR model or binomial model, whatever you want to call, is viable and complete. Both viable and complete. Now let's stop for a moment, and you have any questions? Let's repeat that. Okay, let's repeat, take 5 minutes to repeat it. This is a binomial model. I have a market probability. The market probability is given by this, right? Now I want to cook up a P star to check arbitrage freeness. Then I am making the following claim, whose proof is very simple. Then for viability, I need this, and therefore I make this assumption that R lies between A and B. And then the main claim, Sn tilde is a P star martingale if and only if Tn's are IID with this distribution. I keep proving it, and in the process of proving, I find that not only does, because the arrows are reversible, not only does P star exist, but the construction tells me that it exists in a unique way. Because this, if you reverse the arrow, you will get only this. Therefore, the market is both arbitrage free and complete, because this is unique by construction. Like, if you have a differential equation and you solve it by a regular method, then the solution, you don't have to worry about the solution is unique or not, because any other method of solution is going to give you the same, right? So if you can find an explicit solution, it's likely to be unique, and this is an explicit solution, right? Now what is the next step to do? Next step to do is to price an option, right? How do you price an option? So I can erase all the claims. Claims are done, right? So this is just a proof, right? Take a look at the proof. If you have questions, tomorrow we will have discussions. And you can find my notes on ICTS website. I think I gave the lectures in 2012. Now, okay, option price. So what is Cn, right? Option price will depend on N, obviously. It will also depend on the stock price. Right? Generally, it depends only on the stock price and many other things. But I know the formula, right? I know the formula. This is option price, right? The abstract theory tells me that this is the option price. If this is not option price, there is arbitrage. So Cn is, the option price is 1 plus R to the power n minus n expected value of Sn minus k plus given Fn. What is Fn? Fn means all the Tn's or the Sns. So that means Sns. Is that okay? Fn means these are the random variables, right? S1, S2, up to and including Sn. But look at the structure. This is what is called a Markovian structure, right? To know Sn plus 1, I don't need to know Sn minus 1. I only need to know Sn. So this is automatically, this is called a Markovian structure, 1 plus R to the power minus n expected value of Sn minus k plus given Sn, right? Only Sn is needed. For the conditional expectation, all this information up to and including n minus 1 is irrelevant because of the tree structure, right? This is the Markovian structure. In order to compute Sn plus 1, I don't need Sn minus 1. I need only Sn. Is that clear? Now suppose, now the stock, so you are pricing at, no, Sn, right? No, Cn equal to up to Sn, right? Last period. No. What I'm doing, so let's see. I have 0 here, 1 here, and I have n here. N is somewhere here. It could be capital N minus 1 and it can be 0. Anything. I'm finding the option price at a prior time. Right? Right? So it is Sn, right? Now when you are finding the option, this is a random variable, but when you are finding the option price at little n, Sn will be known. You observe Sn and then price, right? That means if you want to price option at 0, right, then you know S0 and then price. If you want to price at Sn, then you observe Sn and price, right? So suppose Sn equal to x. You have made this observation. So on this observation, it will be Cn will be equal to, Cn will be a function of x and many other things. This will be 1 plus r to the power n minus n, conditional expectation of Sn minus k plus given Sn equal to x, right? Given Sn equal to x. This is not a random variable. Random variable has been observed, and its observed value is x, so this is going to be a number. And how do I calculate that number? This is equal to Is that okay? Sn equal to this. I have not played with this. Sn, this quantity is equal to S capital N, right? It's kind of a telescopic product, right? But now I know Sn, this is no more a random variable, right? These are the random variable. So this is equal to 1 plus r to the power minus n expectation of x product Pi I from n plus 1 through capital N minus k plus, right? Just I have plugged Sn equal to x, and this is equal to, now look at this, this is very easy to compute. Why? Because all these TIs are IID, and therefore this will break up. So Ti is equal to either 1 plus A with probability P or 1 plus B with probability 1 minus B. So the result is Cn of x is equal to 1 plus r to the power n minus n j from 0 to capital N minus n minus n factorial over j factorial times n minus j factorial p to the power j 1 minus p to the power n minus j x times 1 plus a to the power j 1 plus b to the power n minus j minus k plus. Is that okay? Binomial distribution, right? So depending on Ti is 1 plus a j times, the remaining times it is 1 plus b, and j can be 0 through n minus 1, and these are all independent and identically distributed, and therefore this is it. So you can use it using binomial theorem or binomial tree also. But then, as I said, the discrete time, with little bit of knowledge of martingales, you can compute this. And then this can motivate you to go further, right? Now the question is, I have answered only one question, namely, this is the option price. What is the other one? The hedging, right? How do you calculate hedging? Right? Hedging has to be calculated, right? So now this is option price. Now hedging. Hedging. Now in hedging, here I have given, here the theory tells me that there exists such phi, right? Phi need not be unique, but there exists such phi. But in practice, I have to calculate phi, right? So what do? Cnx equal to, what is Cnx? This is the option price, right? Option price must be the value of the portfolio, right? The value of the portfolio is, if you use my previous, this is the number of bonds that I have bought, right? This times 1 plus r to the power n, right? Plus, so let me Sn, plus phi n Sn. So this is the portfolio, right? This is the portfolio value. This is the portfolio value, right? Portfolio value for a portfolio of 2 stock and bond, right? And this is the portfolio value is a random variable. So is the option price. Since the 2 random variables are equal, for every realization they must be equal, right? And the realizations of Sn, I can go to the realization of Sn in terms of Sn minus 1, right? So this will be, this tells me that phi 0 n 1 plus r to the power n plus phi n Sn minus 1 1 plus a is equal to Cn Sn minus a times 1 plus a. This is if the realization is 1 plus a, right? There is one more possibility, the realization can be 1 plus b. So I have one more formula, phi 0 n 1 plus r to the power n plus phi n Sn minus 1 1 plus b equal to Cn Sn minus 1 1 plus b, right? Is that okay? This is the result, right? The value of the option must be equal to the value of the portfolio. Both are random variables, and these 2 random variables are equal, means for every sample point they will be equal. So the sample point has 2 possibilities. It is Sn minus 1 times 1 plus a, or Sn minus 1 times 1 plus b. In either case, I have this formula. But note that if Sn minus 1, suppose this is some y, this is what you observe, right? Because your strategy is predictable. So only Sn minus 1 you know. At the time of deciding at the nth stage, you know Sn minus y. So Sn minus 1 equal to y, right? So I have phi 0. Now this can be anything, right? phi n plus, no sorry, what is phi 0 n 1 plus r to the power n plus phi n times y1 plus a is equal to Cn one plus ay, right? This is known by the formula, right? And 1 plus r to the power n plus phi n y1 plus b equal to Cn 1 plus b times y. This is also known, right, by the formula Cn of x, right? And therefore I have two equations. This is an unknown quantity. This is an unknown quantity. Two equations. This will uniquely solve, right? Right? So solve them uniquely. So this gives me the hedging strategy. Right? Hedging strategy is also known. So in binomial, you have the explicit formula and you have the explicit hedging strategy. Okay. So as I said, this is completely unnecessary. This mathematical theory, you can think that this is completely unnecessary, but in continuous time, this level of sophistication is not possible. It will need at least, if you are MSc in mathematics and you have 2 years of training in probability and probability alone, then it is possible. Otherwise, no. So I still am left with around 8-9 minutes. So either you ask question or I go into the continuous time. You have any question? No question. No question can be disappointing. Okay. So it's explicit, right? What you can do is, now you know that what is the limit of binomial? Limit of binomial, there is something called a central limit theorem, right? So limit of binomial is Gaussian distribution, right? So using this formula, using this binomial formula, one can take the limit and derive the continuous time formula. Continuous time formula can be derived using this, provided you know the central limit theorem. So that part I leave, I mean, just introduction of continuous time without getting into the details. Just a very gentle introduction, and I will, tomorrow I have 1 hour 45 minutes, I will complete that. Very, very preliminary. And I will do the continuous time not in abstraction. As I said, this is very, very complicated. I will do using an example, right? So I have a market. As like the binomial market, I have one bond and one stock. This is in continuous time now. One bond and one stock, right? So bond I denote by BT. And this will be e to the power RT, right? R is the risk-free interest rate, so it will be e to the power RT, right? So symbolically I can write dBT by dt. No, this is not symbolic. This is R e to the power RT, right? This is R BT, right? Yeah. So symbolically I can write dBT equal to RBT dt. So what is the R indicates? R is the risk-free interest rate. It's often called the return, right? Interest rate or return. R is the return. R for return, interest rate. Interest rate, right? So you need a modeling for stock, and I will not go into the abstraction, right? So ST is the stock price. Stock price is ST, bond price is BT, right? Now stock price will change. It's a stochastic process. It will change, and you have to observe the change, right? So what is the change? I am doing very, very heuristically. So in a small time interval, the change is denoted by DST. So think modeling terms, not precise mathematical. So change is important. Okay, how much it changes in a small interval of time. But suppose 10 becomes 11, change is 1. 100 becomes 101, change is 1. Are the two changes comparable? No. So whenever we are talking about change in any financial decision, what is most important is the relative change, right? So the relative change will be this, and this is the quantity that is of primary interest to us. So what will it be? It will be, look at this, dBT over BT is R dt, right? What is the R? R is the growth rate, return, right? So here there will be a growth rate, right? So there will be a growth rate, let's call it mu, right? The growth rate is mu, and I'm assuming that it's constant over time, okay, dt. But if this is the equation, then the stock market, then if this is the equation, then ST is going to be equal to e to the power mu t times S0, right? Then it's predictable, deterministic. Then there is no game at all. If the stock market is deterministic, if you can predict what's going to happen, if you know the stock price now and then you are going to predict, then there is no game at all, right? So there is no uncertainty here, right? So you have to bring in uncertainty. And how do you bring in uncertainty? You bring in uncertainty by adding what is called a noise. Because there are many, many uncertainties, so you add a noise. So multiply it by sigma, some positive quantity, sigma is some positive quantity, and then some noise, right? So Srikanth has done stochastic calculus, right? So suppose WT is a Brownian motion, right? Then you take dWt. It doesn't make sense, but this is the relative change, the change in the Brownian motion, right? So here, this is a Brownian motion, its change is this. In other words, dSt is equal to mu st dt plus sigma st dWt. This is a stochastic, he has done stochastic differential equation, little bit, right? So this is the stochastic differential equation. Stochastic differential equation is a misnomer, okay? What this means is, because dWt does not exist, the Brownian motion is nowhere differentiable. It is everywhere continuous, nowhere differentiable, so dWt doesn't make sense. On the other hand, this makes sense. So remember, this is a stochastic process. You are integrating with respect to Brownian motion, which is another stochastic process. So this is a stochastic integral. This stochastic integral makes sense. So has he solved this stochastic differential equation? He has solved it, right? So we know the solution. Now 1 more minute. The solution becomes, and I will explain what the solution means. So tomorrow's lecture, this will be the starting point. This is the model of stock. That's only model of stock that I am going to describe and the consequences of this model. 1 hour 45 minutes, I will complete this. So all your questions tomorrow.